Now let's take a look at different type of factoring binomials. If your quadratic equation looks like this, x squared plus bx plus c equals to 0, sometimes you can factor it if you can think of two numbers that multiply to give you c and add to give you b. Let's see how this works in this example. X squared plus 6x plus 5 equals to 0. Now we are looking for two numbers that added give you 6 and multiplied give you 5. Okay, well, let's try guessing. What numbers added give you 6? Well, one example is 2 and 4. 2 plus 4 is 6. Now, do they give you 5 if you multiply them? 2 times 4 is 8, so no, this does not work. Let's try another pair. What numbers added give you 6? 1 and 5, because 1 plus 5 equals to 6. Now, do these numbers multiplied give you 5? Yes, that's right. 1 times 5 is 5. So we found two numbers that work. And now we can factor this expression out like this. X plus 1 times x plus 5 equals 0. So I just wrote 1 here and 5 there. If you multiply it out and you go x squared plus 5x plus x plus 5, you will see that you get that same expression. So it's just a different way of writing this quadratic. But what happens when you write it in this form is your roots become obvious. Why is that? Because we are setting this to 0, and the only time when this expression is going to be 0 is when either this is 0 or this is 0. Well, when is this equal 0? When x equals to -1, because -1 plus 1 is 0. So that's one root of our quadratic, x equals to -1. And the other root is when this equals to 0. And that happens when x is -5. So x minus 5 is our second root. And here we found two roots of this quadratic equation. Let's take a look at another example. X squared plus x minus 6 equals to 0. Now we're looking for two numbers that multiplied gives us -6 and added give us 1. Now what numbers could they be? Well, let's just give it a try. So we're looking for two numbers that multiplied give us -6. Well, one example is -6 and 1. If I multiply these two together, they give me -6. But if I add -6 and 1, I actually get -5. So that doesn't work because I do not get +1. This pair is out. Let's think of another pair. One I can think of is -3 and 2, because -3 times 2 is -6, so that part works. How about if we add them together? -3 plus 2 is -1. Well, it's pretty close, but we don't get +1, we get -1. So that does not work. Let's try -2 and 3. If we multiply -2 by 3, we get -6. But if we add -2 plus 3, we do get 1. Great, so this pair works. Multiplied, these two numbers give us -6, and added, they give us +1. What that means is that this quadratic can be written like this. X minus 2 times x plus 3 equals to 0. So I just take these numbers and I write them after x. That's how we factor it out. Now to find the roots or the solutions to this, we have to set this equal to 0. So this product will be 0 when either this is 0 or this is 0. And this will be 0 when x is equal to 2. And this will be 0 when x is equal to minus 3. So these are the two solutions to our equation. Remember not to confuse these numbers with the solutions. You see how while these numbers are the ones that helped us factor it, the actual roots are a bit different. The signs are different. Note that you can always check if you have factored the quadratic correctly by multiplying it back out and seeing if you get the same expression. So I factored this quadratic out and I got x minus 2 times x plus 3. How do I check if this is true? Well, I can just multiply it out. So what I'm going to do is multiply this times this, and this times this, then this times this, and this times this. X times x is x squared. X times 3 is 3x. Negative 2 times x, negative 2x. And minus 2 times 3 is negative 6. Now when I simplify it and I combine 3x minus 2, I get x squared plus x minus 6. So you can see I get exactly the same quadratic, and I know that this has been factored correctly.